What's going on, folks? It's Mike here, and welcome back to the SDL series in C++. And in this lesson, we're going to be talking about sound to make our applications just feel a little bit more dynamic, build some atmosphere into our multimedia and game applications, and just understand what options are also out there for adding sound. So with that said, let's go ahead and dive into this lesson. So the first thing that I want to do when talking about sound is just tell you what options are available. There's a lot of different audio libraries out there, and they have different licenses or different ways to put sound into your games or multimedia applications. Applications like OpenAL, which is free for use for various platforms and commercial applications and is very popular, can be found here. We have Fmod, which is a very popular commercial sound library and free for non-commercial games, although you might want to check the license to see if that's been updated since the recording of this video. And we've got things like SDL Mixer as well, because, well, this is the SDL series. And this is a library that's built and externally available that we can use. Now, while I might eventually want to talk about SDL Mixer, I actually just want to take us to the documentation here and start with the basics here by talking about the SDL Audio API. So that's built in, we don't need to install any other libraries, and our goal today is just to be able to build a sound and start building our library. So I'm going to go ahead in the documentation and go ahead and open up under the audio section here the documentation for audio management and playback that's built into SDL, and it works for most platforms that are available. But before I dive into the actual code and show you what's been built and added to the support code, I want to just talk about sound a little bit in this chart that I have, because I think it's a little bit important to understand what sort of data you're working with. For instance, when we've talked about surfaces, we've talked about pixels, with sound we should at least understand what we're working with. And essentially, sound itself is in waves, and it'll look something like this, maybe going below this axis for time, for pressure. I'm just going to draw a simple wave here, so you get the sort of idea here. And waves have a specific amplitude here, and I'll just label it quickly. And that, in the simplest terms, the amplitude you can think of, well, something with a really big amplitude here is displacing a lot of air and going to make a really loud sound. That's one way you could think of it, if you've ever seen that visualized on different tools. Now, the distance between the top of each of these waves represents one cycle of that wave. Now, some other ways that we might think about our waves here, and I'll go ahead and just undo this, is also the pitch of the wave. So if we have very frequent waves like this, we'll get a higher pitch versus something that's maybe slower rolling. So that's just to give you, again, an idea of what a sound wave looks like, and maybe this is a refresher on some of the things you've learned about from waves in your physics course or just other places you've seen. But what I really want to talk about for today's lesson, since we're going to be using SDL to represent and play a sound, is that when we have these waves here, we're actually getting samples from these waves here. And actually, the easiest way for me to do this is just draw a few points here, because our machines can't truly capture all of the data that's out there when we make a sound. We have to sample at some point. So I'm just going to draw little rectangles here approximating the sampling rate of our sound wave. And for those of you who are sound gurus or musicians, you might know that this is roughly a range of about 44.1 kilohertz, or 44,100 samples per second, which is a lot. And some folks say that's sort of indistinguishable between a true sound if we can represent that. So again, what this really looks like in our actual code is we're just going to have a giant array in our sound data with different values here representing each of our points here for the amplitude of this wave, or whatever our y-axis is for how sound moves, say, in air. And again, we can get really wild with this, moving in different materials and all sorts of different ideas. So anyway, I hope that just gives you a little bit of the intuition as to what we're actually storing in an array. It's these little sound points here in our sound data. Now, depending on how good of quality of sound we want, we can use different formats. The WAV format is the default format supported by SDL Audio. In fact, that's the only sort of basic format that's offered. And then you would use something else like what's displayed here, SDL Mixer, for loading other file formats. Most folks, I think, are pretty familiar with MP3, as that is what a lot of music is stored at. And that's what's known as a lossy format. That means the data is compressed so that it's smaller, easier to distribute, and generally the quality is good enough that we're not going to really distinguish between the sound. Unless you're, of course, listening very closely to something, then you might pick up some of the artifacts. But in a game, we might be able to get away with sort of more lossy formats in order to distribute, say, an app where it really matters how small the file sizes are. Anyway, so that's just the idea, some basics of sound, how it's stored in an array, and some of the formats that we might think about here. So anyway, let's get to the important part, which is the code, and just worry about for today getting a sound up and running. So with that said, let's go ahead and look at some of the code that I've built. And first, I just want to actually introduce just the audio API here. And you're going to notice that SDL's audio API is quite low level. We're working with opening and closing devices and working with WAV files. You'll see the ability to free a WAV file, load a WAV file, maybe lock audio, and do some various low level things. But for today, our goal is just to be able to play a sound and start thinking about maybe the sound design in some future lessons to make things much more detailed, because sound is a really important part of games and multimedia applications. Anyway, that's enough on that. So where are we going to start here? Well, quite a while ago, we had a SDL init function. And if you might remember, we initiated, and to this date have only really used the video system here. But we're actually going to now want to initialize the audio subsystem. So again, the great thing about SDL is we can enable these subsystems that we need and disable the ones which are off by default that we don't need. So our applications are very efficient. So that's the first thing that we're going to do. So I just want to go ahead and show you here. I've made a slight change into some of our code for those who've been following the series from the start here. And let me go ahead and just show our SDL app. So our SDL application, we're now going to initialize any of the subsystems that we need. So if I go ahead and show you where this is in our main program, where we have SDL app, and down here, you'll see that we're initializing the video system and the audio system. Okay, and let me go ahead back to the actual SDL app code so you can see that. This is all we're doing. We're now just passing an argument to initialize whatever the subsystems are. So this is a little trick here where you can use a bitwise operator to take, or rather OR two flags together, and that'll just be interpreted as one integer here. And then there's some bit shifting tricks you can do to see which subsystems are enabled. So if you need a little refresher on that, feel free to check that out. That's sort of an old C trick. So anyways, once we've got our SDL subsystem initialized for audio, then we can actually start doing some work with our audio system. So I'm going to go ahead and just open up our sound code here so I can start showing you what I've done. So I have a new sound HPP file that's in the bottom right corner here, and a new sound file here on the left that's doing the implementation. And then in the top right corner here, you'll see where I'm creating one sound. Okay, so when working on a code base, where you always sort of want to look at when you're building some code is the interface. So let's go ahead and focus on that, which is right above me here. And the first thing that you're going to notice is that I built an interface for sound here. And you might ask, well, Mike, why are you doing this? Well, the reality is eventually I might want to use Fmod or OpenAL if I eventually want 3D sounds or these different things. And I might not want to replace in my code all of my sound code. So I am going to actually have an interface for audio. Now, audio tends to be one of those things where it sort of makes sense because we have a lot of different interfaces that we might want to support, or different devices, for example. So For this, I'm just going to simply have the ability to play a sound and stop a sound at a minimum, because that's ideally all I want to be doing in my code. Now, you're going to see I do a few extra things in today's code, but again, for our API, at a minimum, we might want to play a sound and stop a sound. We might want other things in our API, which we might want to think about, like checking if the sound is playing, if it's stopped, the ability to pause our sound midway, the ability to loop our sound. Those would all be common features that you might want to support in your API. But this is what we have in our interface for now. So we're going to have a constructor where we're going to be able to load a file, a destructor, and then again, the ability to play a sound, stop a sound. And because this is specific to the SDL Audio API, how to set up a device. Now, this could be part of the constructor for this sound or abstracted elsewhere, that is into some audio manager class, some sort of singleton class for that if we want it. But for now, it's just existing here for simplicity. Now, the other parts of our audio, particularly in the SDL Audio API, is to have a device. And that's a simple way of saying, well, maybe you're playing through your speakers or your headphones or some specific sound card, or maybe you have a 5.1 or 7.1 surround system or whatever. Those are the different devices that you want to play sound. And the rest of these member variables, the audio spec, wave start, and wave length, have to do with the actual sound data. So that would be in the audio spec, and then where does that data start, and how long is that, or how much information do we have there? So let me go ahead and walk you a bit through the actual code here. Then I want to show you the documentation, show you the code again, and then we'll actually just run the application where you can see that I made the sounds here. So just at a high level, what we want to do with the sound is, again, load the file path, load the wave file. So this is something built into SDL, SDL_load wave, the file path, and then I'll talk about these arguments here, but essentially we're populating them in this function. So again, C way of filling in variables or populating them is to pass in a pointer, in this case just the address of our member variables in here, to populate our data from our wave file that we have loaded. And then in our destructor, we're going to free that wave file. Again, that's the SDL way of destroying our resource and then closing our audio device. And then in the play sound member function here, what we have is a audio queue that we're going to have because, well, our audio device we want to send sounds to, and they'll get queued up so that they can then play. And we play them by calling this SDL pause audio device function, which is a little bit weird, but if you look at the second argument, it sort of makes sense that we're saying, hey, this is 0 for false, that it's not paused, if that's helpful to think about. So when we want to stop a sound on our device, we send in 1 here, which is true, which means pause our audio device from playing any sounds here. And the setup device function, well, we're going to open some device. The first argument really just stands for requesting some audio device. So maybe that's your headphones. Usually it's your default or some reasonable audio device that is chosen. Again, you can sort of query for these things and dig into the API a little bit more if you want to have an options menu in your game. For now, I'm just leaving this as null. The audio spec here is the data that we loaded actually in our wave file. And what the SDL API is trying to do here is sort of just say, okay, you've got data that's sampled at this rate or has some other property, and it's trying to set up things in a reasonable manner. Or say, if you want to play these types of sounds, here's a configuration for the audio device that makes sense here. And that's what this last flag does. That allows us to sort of SDL to make some changes based off of that. Okay, so that's really it for the SDL code. We have the ability to open a device, pause or play the music, cue the music to be ready to play, and then some functions for loading a file, and then of course destroying this resource and closing our device. That's really it. Now let me go ahead and walk you through that in the documentation, then we'll get to the end where I actually play the music and you can see how I do that. Again, I think it's just helpful to see which documentation pages that we're looking at. So again, for loading a WAV file, this is your option if you're just using the SDL Audio API, to be able to just load WAV file formats. We don't have MP3 or OGG or other file formats, or MIDI, or any of the other common formats that you might have seen in various games here. So again, just walking through the WAV format here, what we are doing on the left side of the code here, loading the file, and then using or populating these different structures here. Our audio buffer, that is, where does our data sort of start, or rather where all the data is, and then the length of that actual buffer. So how big is our WAV file? And then the spec here is the structure that just fills with the format details. What rate was it sampled at? And various other details. In fact, we're going to look at this next here. So you can see a little example here of how to do this. So the SDL audio spec, again, this is a C-based structure here, and you can see some of the different properties that we would have for a sound here, like the frequency here, the actual format, how many channels there are within the sound file. So for example, if you've ever composed music, maybe there's different ways that you've recorded the music. So maybe you have stereo sound, or again, multiple speakers set up all over your studio, so you can get that sort of 5.1 or up to 7.1 surround sound or whatever it is now. So those would be some of the different attributes here. The sampling rate, again, some number like how big to make these sort of basically how many samples you're going to have in your audio buffer. So anyway, this is the stuff that's stored in this structure. Now there is something here that's sort of interesting here, and you might see in other SDL audio tutorials, the SDL audio callback. This is the function that you can actually have called and played in a different thread whenever you want to play some sound using SDL audio. Now we're going to get away with not using that by just using the SDL audio here, which allows us to, let me go ahead and have both of these here, just sort of send the data to our sound card or whatever our audio device is, and just play something from the start to the finish here. Okay, so anyway, here is the information we have here in our audio spec. So the other things of interest here before we can sort of play our sounds is, well, we have to have some sort of device. Again, whether that's just playing through your headphones, your speaker, or whatever here. So we have the actual device and some other properties we could set. For example, if you're trying to capture audio, like I'm speaking into a microphone right now and recording for you folks, or if you're trying to play back. So that just depends on if you make this a 0 or 1 value. Again, really low level and lots of different flags that we can change here with the sort of raw SDL Audio API. So with that said, let's go ahead and get to the Q audio here, which again queues more audio on non-callback devices. So this means we don't have to take advantage of that callback option. If folks really want to see a separate tutorial on using that, I could redo this lesson here, just put a comment below. But it's easier to just sort of queue audio and have it played, at least in the instance that we're going to be using here. So whatever the device is that we set up here, and let me go ahead and show where we set up our device here. That's in this function here. So we capture whatever the device is that's set up in this member variable here. So we have SDL audio device ID. So again, maybe we have different IDs for headphones, speakers, etc. And then the different properties that we set it up for. Again, that's what we're passing to this Q audio function here. And then the actual data that we want to play back. So that would be our audio buffer. In fact, that's just our wave start, and then the wave length. How many bytes that we want to play? Well, the length of our entire sample is usually what we want to play. And this is where things can get interesting if you have a bunch of different sounds in the same file, or a bunch of different clips, and you want to just play a portion of that clip. These are the different parameters that you could control. All right, so finally, we have our last function here for playing and stopping sound. Again, I have SDL pause audio device for that. The device, again, that we're playing back the sound on, and then whether we have paused the sound or not. So if we are going to play the sound, we have 0. If we are going to pause the sound, we have a non-zero value, which would be 1 to have it played. Okay, so with that said, I know you're excited about actually playing some sounds here. Again, it's only really 6 or 7 new functions here, but it's not always super intuitive, and a lot of the tutorials I've seen on SDL don't explain or sort of show stuff in an easy way. So hopefully this is useful, but again, you probably want to just see the code here. So in our main function here, main program, let me go ahead and walk you through what we have added here. I'm just going to create a sound. So I'll include our header here. So we have our interface, and we're going to play a sound every time a collision happens in this little demo here. So we need to initialize that sound here. So this is down in my main function. I'll scroll down here, and the collision sound, we will play a new sound, and we'll load from our assets folder a new sound and a little collide sound. In fact, let's go ahead and just open up this folder here so you can hear what it sounds like. And let's go to assets, sounds, and let's go ahead and just play it here. Actually, I'll just close it down and just play it for you in the actual program. But I do have to call this setup device function. Again, I have this little to-do note here, just suggesting that it might be nice to even have a manager class for audio that sets up these devices. Again, you could imagine this is something that's configured once by someone playing your application and just setting whatever the sound settings that they want and so on. For now, per sound, we're going to set up the device. Again, this could be part of the constructor or managing class. I'll probably fix that in some future lessons, so you'd have the support code available. Okay, so as far as playing our sound, once we have it, I'm actually just going to play this every time that there is a collision here. So if you recall from previous lessons, or maybe this is your first one that you're seeing, I have our handle events callback here, and in our event loop here, anytime I click the mouse here, I attempt to detect if there is a collision between my one object that has one collider and then my second object that has 2 collider boxes, so 2 different points where it could collide. And then I simply call this function collision sound play sound. And I do that for each of our different colliders. So with that said, let's go ahead and just see the final program here playing. And I'll put on a headphone so I can listen with you folks. And I'm going to click, and you're going to hear the sound once per hit. And if I click my mouse like I did, it's detecting 2 presses. So maybe we want to click or only detect our mouse clicks on an up press. So you're going to hear a bunch of times. Ready? So you hear that sort of hit sound there every time that it's colliding when I'm holding my mouse down. So that's it. It's as simple as that. So with that said, we've learned a bit about sound today, how to create raw sounds using the SDL Audio API, and we've seen that it's really not too bad. Now we are probably going to have to add some abstraction. Again, if we want to loop the sounds, check if the sound is playing, maybe queue up different sounds on our device so we can have multiple playing at once and sort of keep track of them. Those would all be further things that you can do with the SDL API, just building on that abstraction. So if you've enjoyed this and maybe you want to see another lesson on SDL Mixer or one of the other audio APIs, leave a comment or a like below. Make sure you subscribe so you can catch that. And I hope you've been enjoying this. We're at the point now where we've got collision detection, the ability to draw sprites, animate sprites, and now play sounds in our game. And we have different components on each of our entities. We've got quite a bit here, and we're almost ready to just start building a game. All right, folks. Anyways, thanks for joining me on this lesson, and we'll see you soon in the next one.